All right, now on to example 4. Here we're looking at, yet again, multiplication of two radical expressions where we have extra stuff out in front of some of these radicals here. So in this example, we're going to be emphasizing how we handle this extra stuff in front of the radicals. And it turns out it's very little different than working with everything that we've done so far. We just have to be mindful of how we combine the stuff out in front, or coefficients of the radicals, if you like. So how do we do this? Rewrite the expression. So we have 4 times root 5 plus root 3 times 3 root 3 minus 2 root 5 as a quantity. Okay. As before, we're going to FOIL this just as we normally would. So take this first thing, multiply it to the first thing over here, and then add that when you multiply this first thing times the second thing. So let's just combine these. I like to do this all in separate steps. So we have 4 root 5 quantity times 3 root 3. Sure, you could write that as 12 times root 5 times root 3 if you wanted to. That's perfectly fine, but I'm isolating steps just to illustrate what's happening here. And then we add on 4 root 5 times minus 2 root 5. So it gives 4 root 5 times minus 2 root 5. Okay. And then we have this root 3 that we're going to multiply to this first thing, and then add that to when we multiply it to the second thing over here. So we have plus root 3 times 3 root 3. And then finally, we have root 3 times minus 2 root 5. So I have root 3 times minus 2 root 5. So it looks long and arduous, and you could have combined things earlier on, but I like to isolate steps just to keep the work painfully clear for the person who's grading my work. And okay, now let's combine stuff. These guys are being multiplied, has nothing to do with anything else, so we just have these two things. So we have 4 times root 5 times 3 times root 3. So this combines to be 12 root 5 times root 3. We'll combine those in the next step. Okay, so that finishes off the first term. The second term, we have 4 times minus 2 times root 5 times root 5. We can change up the order of multiplication because multiplication is commutative. So since I have a minus 2 here and a plus 4 here, this plus is actually supposed to be a minus. So we have minus 8 root 5 times root 5. Okay? And now we're done with this term. This term, we have 3 times root 3 and another root 3 here. So this becomes, well, we don't really have anything out in front of this guy, so it's just 1 times that 3. So we have 3 times root 3 times root 3. So we're done with this term. This term, we don't have anything out in front of this root 3, but that's okay. We just are left with minus 2 from this guy times root 3 times root 5. So I just reorganized the order of the multiplication here. That's all I did, and that's all I did in each of the other terms as well. Just reordered the multiplication and combined stuff when I could. All right? So at this point, I'm going to put everything under one radical. So in each of these terms. So I have a 5 and a 3 here. If I combine those under one radical, first thing I'm going to notice, I'm going to get 15, but 15 breaks down into 5 times 3, and 5 and 3 don't break down any further. So we'll be left with a square root of 15 inside a radical here. So I'll rewrite that. Square root of 15, because 15 is not going to break down into groups of powers of 2. And in this case, I do get a power of 2 because I have 5 and 5. So when I put these all under one roof, I have root 5 times 5, which gives me 5 squared, square rooted, and that just gives me 5. So I have 8 times 5 in this case, because I was able to cancel these out. I'm skipping a step there. Hopefully that's okay. And if not, I'll redo the video. Just let me know. So in this case, we have a similar circumstance where we have 3 inside a radical and a 3 inside a radical, both being multiplied. So we have 3 squared, all under 1 radical if we use the power rule. So this gives us 3 times 3, because the square root canceled the squared of the 3 here. Again, skipped step. So continuing on, I have a 3 and a 5 inside radicals. These don't break down any further, so I can't cancel the radical, but I can put them all under one roof. So we have root 3 times 5, or if you like, 15. So let me just change that to a 15 instead. Okay, so let's simplify some of this multiplication here. So we have 12 root 15 minus 8 times 5. All right, and we also have this 3 times 3, and we also have this minus 2 times 15. So 8 times 5 is 40. And we have 3 times 3, which is 9. Okay? And now we have this minus 2 root 15 to worry about. So we just carry that along. Combine yet again. So we have 12 root 15 minus 40 plus 9. So let's combine these guys. That gives us minus 31. And then we have a minus 2 root 15. So we're just carrying that along. Just simplifying, combining things where we can. All right, so now I'm looking at 12 root 15, and I have minus 2 root 15s over here. So I have 12 of the root 15s and minus 2 of them. How many root 15s do I have in total? I have 10 of them. So that gives me 10 root 15s minus 31. Okay, so at this point, I can't break down the 15, as I mentioned before, so I'm left with just 10 root 15s, and I have minus 31. 31 is a prime number, so I cannot factor anything out of this, and I can't factor anything out of the entire thing because of 31 being prime. So at this point, this example is done. And with that, I will see you in the next example.